Tandem breakers count as two spaces in an electrical panel. The National Electrical Code, specifically Section 408.16a, states that a panel board should not have more than 42 overcurrent devices installed within it. This includes any supplementary overcurrent protection devices, and the rule applies to panel boards that are rated for 225 amps or less. Consider a situation where there is a 200 amp 42 space panel that is already filled with single pole 20 amp breakers. In this case, adding a tandem breaker would indeed violate the National Electrical Code rule. A tandem breaker, by its design and function, effectively utilizes two breaker spaces within the panel. Therefore, adding just one tandem breaker to an already full 42 space panel would increase the total number of spaces occupied to 43. This exceeds the maximum limit of 42 overcurrent devices allowed by the NEC in this scenario. The code is in place to ensure safety and prevent overloading of the electrical system, which could lead to overheating, fire hazards, and other dangerous situations. It is essential to understand this requirement when making modifications or additions to an electrical panel. Firstly, always consult the panel board's label. This label contains critical information, including the maximum number of overcurrent devices the panel is designed to accommodate. Secondly, be mindful of the physical space available within the panel. Even if the panel board is rated for a certain number of overcurrent devices, the physical layout might restrict the types of breakers that can be installed. Thirdly, understand the different types of breakers available. Single pole breakers typically serve one circuit, while double pole breakers serve two circuits and require two panel spaces. Tandem breakers, also known as half-size or slimline breakers, are designed to allow two circuits to be installed in a single panel space, but they still count as two overcurrent devices. Let's consider the implications of exceeding the 42 overcurrent device limit. One major concern is overloading. Each circuit in the electrical system is designed to handle a specific amount of current. If too many circuits are added to a panel without increasing its overall capacity, the system can become overloaded. This can cause the breakers to trip frequently, which is inconvenient and potentially dangerous. Furthermore, an overloaded electrical system can generate excessive heat. This heat can damage the wiring, insulation, and other components of the system, increasing the risk of electrical fires. In addition, exceeding the maximum number of overcurrent devices can void the panel board's listing and warranty. This means that the manufacturer is no longer responsible for any damages or failures that occur as a result of the overloaded system. It's also important to recognize that local electrical codes may have additional requirements or restrictions beyond those specified in the NEC. Always check with the local authorities to ensure compliance with all applicable regulations. When faced with a situation where additional circuits are needed but the existing panel is full, several options can be considered. One option is to replace the existing panel with a larger one that has more spaces. This can be a costly and time-consuming project, but it may be the most effective solution in some cases. Another option is to install a subpanel. A subpanel is a smaller panel board that is fed from the main panel. This allows additional circuits to be added without overloading the main panel. However, the subpanel must be properly sized and installed to ensure safety. A third option involves identifying any circuits that are not being used or that can be combined. For example, if there are two separate circuits for lighting in the same room, they may be able to be combined into a single circuit. Remember that any electrical work should be performed by a qualified and licensed electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent injury or property damage. In the example previously mentioned, the full 42 space panel with 20 amp single pole breakers presents a common scenario. To reiterate, adding a tandem breaker in this situation violates NEC section 408.16a. Now let's dive a little deeper into the specifics of NEC section 408.16a. The code explicitly refers to overcurrent devices. An overcurrent device is a component designed to protect an electrical circuit from excessive current. Circuit breakers and fuses are the two most common types of overcurrent devices. The purpose of an overcurrent device is to interrupt the flow of current when it exceeds a safe level. This prevents damage to the wiring and equipment connected to the circuit, and it also reduces the risk of electrical fires. The 42 overcurrent device limit is intended to ensure that the panel board is not overloaded. When a panel board is overloaded, it can generate excessive heat, which can damage the components and increase the risk of fire. By limiting the number of overcurrent devices, the code helps to prevent overloading and maintain a safe operating temperature. It's crucial to also consider the ampacity of the conductors connected to the overcurrent devices. Ampacity refers to the maximum amount of current that a conductor can safely carry. The conductors must be sized appropriately for the overcurrent devices they are connected to. If the conductors are too small, they can overheat and potentially cause a fire. NEC Table 310.15b16 provides guidance on the ampacity of conductors based on their size and installation type. This table should be consulted when sizing conductors for any electrical installation. Let's consider a hypothetical scenario. Imagine a home with a 200 amp service and a 42 space panel. The homeowner wants to add a new air conditioning unit that requires a 30 amp 240 volt circuit. The panel is already full of single pole breakers. In this situation, the homeowner cannot simply add a tandem breaker to make room for the new circuit. Adding the tandem breaker would violate the 42 overcurrent device limit. Instead, the homeowner would need to consider other options, such as replacing the panel with a larger one or installing a subpanel. If the homeowner chooses to replace the panel, they would need to ensure that the new panel is properly sized for the service and that it meets all applicable code requirements. If the homeowner chooses to install a subpanel, they would need to ensure that the subpanel is properly sized and installed and that it is connected to the main panel in accordance with code. Remember that electrical codes are constantly evolving. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest code requirements to ensure that all electrical work is performed safely and in compliance with regulations. To further illustrate the concept of overcurrent protection, let's discuss the different types of circuit breakers. There are several types of circuit breakers, each designed for specific applications. Standard circuit breakers are the most common type of breaker. They are designed to protect against overloads and short circuits. Ground fault circuit interrupters, commonly known as GFCIs, are designed to protect against ground faults. A ground fault occurs when current leaks from a circuit to ground. GFCIs are required in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, commonly known as FCIs, are designed to protect against arc faults. An arc fault is a dangerous electrical condition that can cause fires. FCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. In addition to circuit breakers, fuses are also used as overcurrent devices. A fuse is a device that contains a metal strip that melts when the current exceeds a safe level. When the metal strip melts, it breaks the circuit and stops the flow of current. Fuses are less common than circuit breakers in residential applications, but they are still used in some cases. It's essential to understand the different types of overcurrent devices and their applications to ensure that the electrical system is properly protected. Now, let's revisit the importance of consulting with a qualified electrician. Electrical work can be complex and dangerous. It is important to have a thorough understanding of electrical codes and safety practices before attempting any electrical work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with code. It can also help to identify potential problems and recommend solutions. Hiring a qualified electrician can save time, money, and potentially prevent serious injury or property damage. Moreover, many jurisdictions require a permit for electrical work. A qualified electrician can obtain the necessary permits and ensure that the work is inspected and approved by the local authorities. This helps to ensure that the work is done safely and in compliance with code. In conclusion, when dealing with electrical panels and overcurrent devices, always prioritize safety and compliance with the National Electrical Code. Understanding the rules regarding the number of overcurrent devices allowed in a panel, the ampacity of conductors, and the different types of circuit breakers and fuses is essential for maintaining a safe and reliable electrical system. If you are unsure about any aspect of electrical work, always consult with a qualified and licensed electrician. Remember that electricity is a powerful force and should be treated with respect. Taking the necessary precautions can help to prevent accidents and ensure the safety of yourself and others. Also bear in mind the importance of labeling. Clearly labeling each circuit breaker in the panel is crucial for easy identification and troubleshooting. This helps to quickly identify the correct breaker to turn off when working on a specific circuit, reducing the risk of electrical shock. Use a permanent marker or label maker to create clear and legible labels for each breaker. The label should accurately describe the circuits they control. For example, a label might read kitchen lights, living room outlets, or air conditioner. Keeping the panel clean and organized is also essential. Remove any debris or obstructions that could interfere with the proper operation of the breakers. Regularly inspect the panel for signs of damage or wear. Look for loose wires, corroded connections, or cracked breakers. If any problems are found, have them repaired by a qualified electrician immediately. Lastly, be aware of the limitations of circuit breakers. While circuit breakers are designed to protect against overloads and short circuits, they are not foolproof. They can sometimes fail to trip, especially if they are old or damaged. It is important to have a backup plan in case a circuit breaker fails. This might include having a supply of spare breakers on hand or knowing how to safely disconnect power to a circuit. The 42 circuit limit as discussed by the NEC is not arbitrary. It is derived from engineering studies that consider heat dissipation, wire bending space, and overall panel board integrity. Exceeding this limit can compromise the safety and reliability of the entire electrical system. Finally, to summarize this entire lesson, understand that tandem breakers, although space-saving, count as two overcurrent devices under NEC section 408.16a. Therefore, adding them to fully occupied 42 space panel violates the code, creating a potentially unsafe condition. Always prioritize safety, code compliance, and consult with qualified professionals.